We have 30 minutes. Let's get started. Today, we are going to demo our EKS Cost Optimizer, and this is going to be a very cool tool for you to use. You can use it for absolutely no cost. All you got to do is come to Cast AI, register, and I'm going to walk you through the steps all the way from registering your cluster, your EKS cluster in read-only mode, all the way through to fully optimizing the cluster using and onboarding the cluster to our automated optimizations. Okay, so to start with, I've created in EKS in AWS. I've created an EKS cluster using just a standard EKS CTL tool. And I've set the default like kind of node group, and I've estimated that my cluster needs a bunch of nodes. I've created 7 nodes. Here they are on my AWS console. And now our goal is, let's deploy something to that cluster so that we can actually have a real application running. And then we'll go ahead and run the savings report to see how much we can optimize, how much room we have to optimize the cluster and right size it. And then from there, we'll go and do a few things with spot instances just to see how all of that works post optimization. Cool, so let's get started. I've got my cluster here. We can do a cube CTL get nodes just to know that we're connected. Yeah, it looks like we're connected just fine. And then I'm going to apply the first YAML file, which is just to create a couple of namespaces. So this is going to be like an e-commerce app that we deploy. We're actually going to look at the e-commerce app. We looked at it in yesterday's high availability multi-cloud demo, and we'll probably look at some additional apps tomorrow during the advanced auto scaling demo. So the next one we're going to apply is this number 3. I'm going to skip number 2, and if we take a look at the YAML for a second, let me just move this Google Meet thing out of the way. If we look at the YAML for a second, one of the services I want you guys to take a look at, and we're going to focus on this, is this recommendation service. I've kind of ballooned out the number of replicas for this recommendation service to give the application some meat. And I've also set the requests a little bit higher than they should. So like we've set the CPU request to 300 millicores, and we've given it a little bit more memory. So the idea here is this recommendation service needs to scale horizontally. It's going to have a lot of work to do. So we need lots of replicas in our cluster. Cool. So I'm going to go ahead and apply this number 3. And we should see all of the services, front-end services, shopping cart services, and then importantly, our recommendation service deployed to the cluster. Excellent. So what I've also done is I've installed, there's a tool called Lens, which is kind of like a Kubernetes user interface. And you'll see that I've already given the Lens tool the kubectl file. So if we take a look at the workloads and we look at the overviews, we'll actually change the namespace to boutique, which is the one that it created. You'll see that the vast majority of the pods are created or kind of in creating state. There's probably a couple more left to create. But the point is the deployment was mostly successful, and we can get started on the next step. Great. So what do we do? Now we have a cluster. We have a deployed application. It's up and running. And we want to go and see how much money we can save on this running cluster. How much is it costing us now? How much money we can save? What are those optimizations? What can we apply? So in order to do that, we're going to go to the CAST console. And what I'm going to do is I'm going to add a cluster by registering this new EKS cluster to the CAST service. So you can do that in a bunch of different ways. I'm just going to do it through the user interface. And what we're going to do is there's 2 options here. There's connect cluster and create cluster. We're not going to create one. We're going to connect to an existing EKS cluster. And you'll notice here that there are kind of 3 tabs. EKS is available, GKE by big demand coming soon, and AKS also highly requested. So these 3 managed Kubernetes services are coming soon. our vision is that we want to allow this analyzer to run in all flavors of Kubernetes in the future. We certainly think there's a huge opportunity on optimizing OpenShift as an example, because you have to pay for licenses and instances. So there's a lot more in this realm coming soon. But so in order to connect this cluster, all we have to do is open up a Cloud Shell or a terminal that's connected with a kube config file and run this very simple read-only script. This will install a cast agent in the cluster, and that cast agent itself is read-only. It doesn't do anything to your cluster. It just observes and reports back data points and statistics of your cluster so that we could go and generate a savings report on your behalf. So we'll go back to our terminal here. And let's go ahead and run this agent install. Excellent. So we want to, apparently the agent is up, it's created, but let's see if the pod is actually there. So I actually have a little command here to query the agent namespace. Yeah, and we see that the agent is running on one of these nodes, 180, and in just a few seconds, we should see that the cast user interface updates to say, oh, look, I have recognized one of your clusters here, KubeCon cluster 7, and I'm waiting for additional clusters. So you could run this script on many different EKS environments simultaneously and get a savings report for each of them. So let's dive in to see what the savings report actually says. I'll give you a moment to kind of ingest all of the data, but in high-level terms, what the report says is, look, you're overspending by about 57.8%, right? Your current bill for these 7 instances is $483. So you're spending 10 cents an hour on M5 Large, which is a reasonable instance that a lot of people use, but we found a better one for you. We think you should be using a C5A Large, and that's running at 8 cents an hour. And you only need 2 of those. And then we also think you should be using some spot instances, right? So this little S here is a spot instance icon. And that actually, there's a small bug here. This is a lower cost, which we're fixing shortly. So the bill is actually going to be lower than this $204, and your savings is going to be significantly more. Now, you could say, look, I don't want to use spot instances. I feel they're risky, so I don't want to use them. So you could turn off the spot instance recommendation in this report. However, the way that the CAST platform deals with spot instances is we automatically deal with the interruptions for you, which is the hard part of using spot. So if your instance gets interrupted, we have a 2-minute kind of shot clock. We will start creating new environments on demand as soon as that notification comes in, and we'll replace the instance with the right new node, whether that's on demand or spot. If there's no spot available, our platform will automatically fall back to on demand. And so if you, so it's a very good case for using spot instances safely, because you as a DevOps engineer don't have to worry about scripting interruption or dealing with the chaos of interrupted instances. Cool. So one of the things you'll notice in this list of workloads is, remember we talked about this recommendation service that's kind of like 15 replicas, right? So that's one of the ones that I recommended for Spot. And later on in the demo, as we get to the optimizations, I'm going to show you how we actually instantiate a Spot instance directly from your deployment YAML file with just like 2 or 3 lines of Kubernetes configuration. You can direct cast to say, no, I don't want this pod on demand instances. I want them on the much more cost-effective Spot instance. So a couple of other things that are coming in the savings report, we're going to be making recommendations around your overall utilization over time. We're going to be looking at the potential to recommend ARM architecture, GPU support for when your pods need or require GPUs. So there's a whole bunch of new and interesting recommendations coming to the tool. So as you run the report over time, you're going to get more insight, including some conformance and security recommendations as well. So let's go ahead and start saving. And this is going to take us to the process where we're connecting our cluster, not in read-only mode anymore, but we're actually going to do a read-write, and we're going to start looking at the auto scaling taking over to make sure we have the right instances. And then we're going to do the migration from the legacy nodes to the cast recommended nodes, and that's what's going to give us our savings. So let's go ahead and start saving. The first thing that the platform says is, cool, you want to start saving, but we need to have IAM privileges for your cluster so that we can take action through API. So in order to do that, you could follow a long set of instructions, or you could just copy this script, and I'm going to paste it here into my console environment. And all it's doing is it's running a set of IAM operations and producing an access key and a secret. So, one thing I should mention is that this user that we've created is very scoped to just this cluster and VPC. I'm going to quickly take the secret. My engineers hate it when this is on the screen, so I'm going to quickly remove it. So let's give access, make sure that that's all good, and then I'll clear the screen and nuke the user afterwards. So great, now we're ready to start saving. And what's going to happen is now that Cast has access to your nodes and your node groups, you're ready to start optimizing. And the optimization really revolves around a set of 3 simple operations or policies. I'm going to quickly describe these to you, and then we're going to go in and start migrating these workloads over to Cast recommended nodes, and then we'll go back to the savings report and watch how that monthly number drops. And if you remember, let's take a note of this. This was a $483 bill, right? So cool. Let's go to policies. So the first one is a limits policy, just to say, I don't want this cluster to go over a certain number of CPUs. We don't say nodes here because our nodes are mix and match. So we really want to focus on the CPU count. So I'm just going to up this to 50. You can optimize your cluster at no charge forever under 20 CPUs. So if you have a small dev cluster or you just want to try this out, you can run this. There's no trial period. You can just run this forever under 20 CPUs. I've got a paid account, so I'm going to 50 CPUs in this particular case. And then we really have just a couple of policies to enable. So the first one is the unscheduled pod policies. And it's very simple. If you have workload that's unscheduled in your environment, this is very similar to kind of a cluster autoscaler approach. The autoscaler will say, we need to create new nodes in your EKS cluster. We're going to go to AWS inventory. We're going to go and run the permutation of all of the requirements for those pods, whether it's zonal placement, whether it's volumes that need to be attached. Maybe you need a special type of spot instance or other type of architecture. So this unscheduled pod policy basically runs through the requirements and says, okay, this is the node or set of nodes I'm going to create for this cluster to be effective, where unscheduled pods go away. And then you can also set this really interesting parameter called cluster headroom. So basically, spinning up nodes is quite expensive. So if you want to leave yourself a little bit of margin so that additional pods that come in can be shuffled in, you can, and then the more aggressive you make this number. So if I made this a number 50%, my cluster would be 2x the size. Yes, I'm wasting money, but my startup time for pods is faster. So I think 10% is about the right number. So once you've got unscheduled pods, you might want to be able to use spot or preemptive instances. So let's go ahead and turn that on as well. And then the other part of optimization is, cool, now I've got my nodes. If my workloads decrease, if my autoscaler, my horizontal autoscaler reduces the number of nodes, or I undeploy something, I want to be able to pack the work into a small number of nodes and then delete those nodes. So the node deletion policy is really just there to take a look at nodes that are targeted for deletion and get them out of your cluster. So notice how we're not setting any kind of CPU barriers. There's no metric here. We're simply working on the fact that when a node is empty, it needs to be removed. And that brings us to kind of the last piece here, which is this evictor. And when we look at migration strategies, there's kind of two ways of migrating your EKS nodes. And I'm going to go into the docs and we're going to look at it in a sec. But one of them is by installing this Evictor add-on, and there's some configuration details for there. We're not going to look at the Evictor today in this demo because we're pretty packed on time. But tomorrow, for Thursday's demo, come to the booth, and we're going to be doing an advanced auto-scaling demo where Evictor will be part of that, and we're really going to kind of dive deep into understanding how Evictor works, where it rolls back, when is it safe, and it makes those determinations for you. So we've got node deletion turned on. We've got all of our policies enabled. I think we're ready to start saving. And if you actually go back to the available savings, you'll see that the savings estimator said, okay, look, you've got your policies enabled. Now we really need you to start looking at migration. So to migrate, again, there's two ways of migrating. The first way of so this documentation just goes through exactly what I showed you. So the first way of migrating is the slow and safe migration route. So look, I don't want any interruption. This is a production cluster. We want to be slow, but over time migrate pods, or at least the pods that are evictable, to the new nodes that we create. So we have a Helm chart for this Evictor add-on, which again, we're going to be demoing tomorrow. And so all you have to do is add us as an official repo, install the Evictor, and then you're going to start to see savings over time, right? So that's cool. We don't have to rush, but in this particular case, we're going to use kind of the faster set of instructions to cordon and drain the legacy nodes so that the cast agent can be really quick about recreating all of the new nodes that it needs, and then we'll get to a result way more quickly, right? So what was our we had our agent running on this node 180. So I'm going to do this rapidly, but I'm going to leave this one node out of the mix, and then that is a we're gonna in case where customers want to just brute force the whole migration, we're going to fix this little thing so that you can do it in one shot. Right now, it takes two kind of cycles to do it. Cool. Let's go ahead and start by cordoning the nodes. Remember, we're going to leave 180 alone, and you can see that. Oh, let's see here. It's yeah, 10 180. Yeah. Okay. We're going to leave this 10 180 alone, and we're going to go ahead and cordon off the rest of these nodes. And I'm using lens just because it's visual. You can obviously do this in command line, but the nice thing here is that scheduling has stopped, and no other pods can be created on these nodes when they're cordoned, right? So just basic thing here. Let me just double check here. Oh, because we're scoped to the boutique namespace, that's why. Cool. So next, after cordoning, we really need to evict the pods that are running on these cordon nodes. So the process of eviction will cause a rescheduling, and that rescheduling will create a scenario where we now have unscheduled pods that cannot fit into our cluster. So let's go ahead and do that. We're going to go ahead and drain. And we're going to drain a bunch of these guys. Yeah, and the process of draining these is really, again, just telling all of the pods in that node to forcefully go away. And it's nice because you can see any errors that show up, you see any kind of timeouts that are occurring, but you can see that all of my services are now kind of in flight. And if we go back to the pods overview for a second, and maybe let's look at, the boutique app, you'll see there's a whole bunch of these warning messages. And if we go to the warning message, we'll say, look, there's no node available for the CPUs we need for this ad service. And there are a whole bunch of warnings here, right? So this is telling the cast system, look, we got work to do. We now have to redeploy a bunch of nodes, or at least enough nodes that will fit the services that require deployment. So let's go back to our node list. And there's a couple of things that you see. First off, you see there's kind of two new instances that were just created 11 seconds ago and 6 seconds ago. And you see also that there are nodes disappearing. So those legacy nodes are disappearing. The cast nodes have come in, and these are the more effective, the more cost-effective nodes that are going to replace. So we now have a new set of nodes that are, we'll find out what the instance types are in just a second. But let's go back to the pods, and you'll see that all of these guys are now going to be scheduling, and all of the warnings are going to go away. So this orange kind of goes away, and we get to a full green circle where all pods get deployed pretty quickly. Great. So how much money have we saved? That's kind of the million-dollar question. So if we go back to the cast console and we look at the savings report, we'll see that, oh, we're already up to 70% of our total consumed savings. That's great. So we went from $483 to $290 in just a couple of minutes here. And we have one more thing that we want to do. So our current, we've still got this M5, node that's costing us some money. I can actually cordon this off now, and we'll do that in just a second in the few minutes we have remaining. But I want to talk about these spot instances. So remember this, if we go back to our recommendation service, what if we wanted to run a portion of those recommendations on Spot? So what I'm going to do is I'm going to go into the replica sets, and I'm going to go to recommendation service, and I think I'm going to scale this from 15 to maybe 5 here. So I'll bring this down so that it's not, but then we have to replace the 10 because the requirements for the application haven't changed. So we still have to, it looks like it's coming back to 15. So let me just change the YAML really quickly. 1 second. So let's go change this YAML to be 5 replicas, right? And what I want to do is I want to have the other 10 come up with spots on a spot instance. So what I've done is I've prepared a spot replicas YAML file, and I've said, I want these pods to run on spot. And the way I've said that is, so you see my replica count here is 10. And the way I've said that is just really through a couple of lines of configuration. The first one is a toleration on the pod that says, look, I'm okay with running on a spot instance, right? This is a key that the CAST platform provides. But more than that, I insist on running on the spot instance, and that's done by this node selector on row 19 and 20. So let's go ahead and deploy these 2 YAML files. The first one to scale our recommendation service down to 5, and the second one to bring our spot recommendations up to 10. So kubectl apply, and then remember we are going to reapply number 3, which is just going to change the replica count, and we're also going to do apply the spot replicas. Okay, cool. Now we have replica set for spot recommendations. It's 10 and 0, and we've got our other recommendation service down to 5. So we're going to see a bunch of unscheduled pods here because the recommendation service that needs to run on spot doesn't have anywhere to go. There are no spot instances available in the environment. It says, look, you have 3 nodes, none are there. Like, there's not much I can do. So I'm going to take advantage of this time here. So we've got these 2 instances that are running. We've got this, we can actually cordon and drain this guy now while we're working. Okay, and then if we go back to our nodes, we should see in the next minute or so that if we go back to our nodes list, you see now that we've got a C5A 2x large spot instance created on our behalf because of the YAML requirement, because of the deployment requirement in the YAML file that said, look, I need a spot instance to run. So we've got these two C5A machines. We've got a spot instance running. We still got this legacy M5, right? But because I just cordoned it off, we should see very quickly that all of the pods were evicted. And then we can actually check where the agent is running. Yeah, and the agent moved over nicely to 219. So in just a second, we'll see this legacy node disappear, and we will have a spot instance that was just created 44 seconds ago. And we should see those recommendation pods fully deployed. Yeah, they're good. They're fully green, right? So the last thing is that we needed to get rid of that 180. It looks like it's gone. What does our savings report say now? So our savings report showed that we went from our original to this new instance. The price is off a little bit because the spot price is off. That's going to get fixed in the next day or so. But overall, we got to amazing savings in just a few minutes. So let me go through again, because we covered a lot in the last 30 minutes. We started with an EKS cluster. We went, and this was our original node list. We got down to a small number of nodes, right? So all of these were terminated. We only have 3 instances running right now. We got to a small number of nodes. We saw our savings report. We got concrete recommendations that you could either implement manually. If you wanted to do that, that's no problem. You could create node groups and do all of the work yourself, or you just say start optimizing, add your credentials, turn on the policies, and then hit the migration feature or the migration process. So very, very quickly, you're able to get to a place where you're spending a lot of money to tremendous savings in just a few minutes. So guys, I really want to thank you for taking the time to view the whole demo.